both portion of the road A, B, C are made of aluminium, meaning that this one the difference is only on diameter. Even from the observation, we can see the difference only on diameter, and it's made from the aluminium with the modulus Young of equal 70 gigapascal. If the magnitude of P, which is a force, is a 4 kilonewton, determine a value of Q. So that deflection at A is 0. Okay. B corresponding deflection at point B. Yeah. Okay. So meaning that if this one we have to uh, use deflection at A. Okay, meaning that A as a reflect to the point C. This one is a fixed support. Okay, if you, even this one we can see is already fixed. Okay, so we don't use delta A as C because it's a, we know here is already a fixed support, right? So we just delta A delta AC or delta A. Okay. Why is my PowerPoint slides like this? Let me check. I think it's because so small, right? Okay, now it's good. Okay, both portion of the road, this one, okay, this one you already. Okay, what you have to do is we have to draw the free body diagram. Okay, if you look at here that you can draw the whole free body diagram. It's possible also, and also if you want to draw part by part, also possible. So we are targeting. If you look at here that we have to determine the value. This one is equal to 4 kilonewton, right? Okay. So what we have to do is we want to determine the force PAB lah. So what we have to do is we have to cut here lah. Force AB. Okay, so it's AB lah. Cut there, right? Point A and B. So this one is P. This one is PAB. Okay. Okay. So first we have to determine the deflections. Okay. For delta AB. Okay. So what we have to do, delta AB equal to, okay, PL divided by AE. Okay. This one you have to remember this equation. AE. Right. PL. Okay. So PAB of course is a 4 kilonewton. Right. L is 0.4. L the length, right? This one lah. You substitute here. Okay. And then area is just distance is in term of the cylinder because it's a road, right? Okay. So pi divided by r square. R pula. D lah. Because diameter is 20 millimeter, right? And E lah. Okay. So E is given this one. So you substitute lah. So you can get deflection of A, B. Okay. Okay. And then we have to determine also the deflections for the member BC lah, this one. Because our target is we have to determine this Q. Okay. So meaning that deflections, the deflections at point A is equal to 0. Okay. Should be the same. Okay. So if you look at here that for the member force BC, okay, so once you determine this one, you already determine, right? So we have to draw against the free body diagram for the member BC, meaning that we have to draw here from this side to this side, right? Okay, so this is how you draw free body diagram to see the easy to this one to understand. Okay, rather than you okay next one. Okay, okay, so you cut there. Okay, so since if you look at here that this one is 4 kilonewton, and there's of course if you look at here, okay, Q, this one is Q, okay. So and then so I think this one is going to be deformation, okay, deformation compressions, okay. So PBC, okay. So but this is just based on the observation, okay. If you get a negative, meaning that the how to say the answer is opposite, okay. This is from PBC. Okay, so if you look at here that from the equations, so we can this one by using total Fy equation of equilibrium, right? Allah. Okay, so I don't think we draw again. So total positive Fy. So we cut from here, right? So P minus Q plus this one and plus PVC lah. So this is a deflection. Okay, equal to 0. Okay, so you can get the PBC equal to Q minus P lah. This one is equation 1. Okay. Okay. So and then we can calculate the what is it? We can express equations in terms of deflection delta BC. How to calculate delta BC? Of course, PL divided by A. Yeah. So if you look at here, P is equal to this one, right? PBC lah. Okay, PBC. So just substitute lah. So you can get the second equation. Delta BC equal to 2.5 times 9 Q minus P. Okay, so it's correct. It is compression because it's for positive. Okay, so this is equation 2. Okay, so it said that deflection at point A is equal to 0, meaning that delta AB equal to delta BC. Okay, okay, delta AB minus delta BC equal to 0 lah. So you can get delta AB equal to delta BC. Okay, because we said is equal to 0. It's stated it should be 0. So this is actually delta AC lah. Okay, delta AC. Okay, equal to delta AC. Okay, so equal to 0 lah. Okay, so meaning that get here, since delta A, so delta A equal to delta AC. This one total equal to delta total. Okay, equal to 0. So we have to make equation delta AB equal to delta BC because it's equal to 0. So even you pull, you compress, the deflection, there's no deflection, is equal to 0 at point A. Okay. Okay. So since AB is in tension and BC is in compressions, so just how to say from the equation number 1 and equation 2, okay, you get delta AB and BC, right? Okay, if you look at here that AB is equal to, you can get the answer, 72. 176 times negative 6 equal to equation 2.5, right? Negative 9Q minus P. Okay, so you can get Q minus P equal to 28.8 kilonewtons. This is equation number 3. Okay. Okay, so we know that P is equal to 4 kilonewtons, so just substitute. Okay, so you can get Q. And then finally, you can get answer for the delta B, BC. Okay, so you can get this one is equal to 4 kilonewton. This one. So just substitute. Okay, so you can get. So if you proceed, this one is similar. Okay, this is the solution. Okay, what we have to do is determine the force for member AB, and then as well as BC. Okay, make do the, what is it? This is the equation 1. Equation 2. Okay, because we substitute this one. Okay, so see, so this one is QC total, because deflection is equal to 0, equal to delta AC lah. Okay, so just this one is delta BC, one is delta A lah, AB. Okay, so you can get Q. P we know 4 kilonewton. Then we can determine delta BC, because delta AB is equal to delta BC from this equation. So you can get 0.0728 millimeter. Okay, is it clear? Okay, it's clear, right? So let's move to tutorial 2. Okay, similarly, move this one, the easiest one. This one later, yeah. This one. So thirdly, the assembly consists of 30 milliliter diameter aluminium bar ABC equal to 70 gigapascal with fixed collar at B equal and 10 millimeter diameter steel rod CD. Okay, so if you look at here that rod CD this one. Okay, and then ABC this one. ABC is the same. Is the aluminium. And then this one diameter is 30 millimeter. Then this one diameter is 10 millimeter. So meaning that it's a different diameter. Okay. What we have to do is determine the displacement of point D lah. Okay, so if you look at here, because of difference diameter and also different compound, okay, materials. Okay, this is aluminium number 1 and another one is a steel rod. So the equation that you have to use is delta what is it? Displacement at point D, right? Delta D. Okay, delta D lah. Because this one is a fixed point. Okay, if no fixed point, meaning that D reflect to A lah. Okay, DA dash A. Okay, if you reflect to the A lah. Okay. Delta D, so by using equation of, what is it? So meaning that delta AD, delta CD plus delta BC plus delta BA lah. Okay, AB lah. Okay, so meaning that this is summation of PI LI divided by EI AI lah. So for each how to say, for each material. Okay, so meaning that we have we divided into 3. Okay, so we divided into 3 because the length is different. Okay, so AB, BC, CD. Okay, so for this one, okay, what we have to do is, of course, delta D equal to P CD LCD divided by ECD ACD plus EBC LBC divided by BC ABC. BC. Betul lah. Plus EAB LAB divided by EAB and EAB. You just substitute all. So meaning that this one's CD this one lah. Okay, diameter E, I substitute here. Okay, and then this one's you substitute into this. Was only the difference in for the length. Length is going to be different, BC and LAB. So you can get answer delta D. So this is a straightforward. Okay, straightforward. Okay, so you can get, if you look at here, divided road into component A, B, B, C. Okay, please remember, do not forget to draw the free body diagram. Okay, so if you look at here, when you divide it, right, this one. So meaning that this is the original, right? Sorry, I didn't use the free body diagram. So if you want to divide it, this one, this, and this, and then this one. Okay, so meaning that how you draw the free body diagram, this one you can draw like this one. Okay, then this one a bit this one. Okay. 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 And then the last one, how to draw? We have to divide pipe by pipe. Okay. So you can see this one is opposite. Yes. And this one also opposite. Don't forget this one, okay? So there's the flossy. This is a free body diagram. For each section, apply free body analysis each component to determine the internal force. This is the internal force. Okay, the internal force. Okay. Okay, of course, this one is 2 kilonewtons. Okay, this one also 20 kilonewtons, same. Only different this one because they have 16 kilonewtons to the upward. Okay, this one outward. Okay, so you can get, I think this one is 12 kilonewton because this one is 20 minus 8 or 12. Okay. Okay. So if you look at here, this one. But this one is if for me, my suggestion, if you want to do the what is it, a method of sections, okay, on the you have this original picture lah. Okay, you draw original and then you cut section by section, just like this. You can see that clearly because this one there's an original picture right on the left side. Okay, so but it's okay, acceptable also this one. Okay, just to see what easy you can imagine more easier. Okay. Okay, so you can get the deflections or deformation is 1.17. So meaning that this one is in tension downward. Okay. And tension downward lah. Tension meaning that is itulah stretch. It's gonna be stretch lah. Because this one you pull, this one also pull. Right? It's gonna be the length is gonna be increased around 1.17 millimeter length. Okay. So it's gonna stretch lah. We call it stretch boleh. Okay. Okay, this one is here. So don't forget the free body diagram. Okay. So okay, last tutorials and then we stop. Okay. So our target is for today is just to uh, discuss about the tutorials. Okay. So if you look at here, that I think this is a quite tricky. Okay, sometimes you have to determine the allowable diameter that required, uh, uh, meaning how to say, sometimes we have to determine by using this method. Okay, we have to determine the exact diameter or the allowable diameter so that your compound shaft is not failure. Okay. Okay, sometimes we have to not only the deflections. Okay. Okay. So this is quite tricky lah. I think this one is we have to determine the deformation and as well as the magnitude of P. So how to determine this magnitude P? If you apply this magnitude, of course, is going to be uh, how to say, this one is going to be moved lah to down. Okay, because you pull this one, right? So it's going to be from the originals, it's going to be to this, going to be, how to say, it's moving. Okay, because this is they have a screw here, right? So it's going to moving, it's a form like a triangle. Okay, so this is quite tricky, like a previous example, if you still remember this one. Which one? This one, right? Something like this. Okay. Okay, so I think this one is for which last year question, I think past year questions. I don't remember in which semester. Okay, so I include this question, I think. Okay, so if you look at here, that BCEG is a rigid bar when force P is applied to point G, strain. Okay, this is a strain. You have to remember the equation of the strain. So if you look at here, that the equation of the strains, please refer to the previous slide. What is the equation for the strain? This one, delta L. Okay, stress divided by length. Okay, this equation, this is what I told you. You have to familiar with these equations, right? And okay, given AAC, EAC, LAC, ADE, EDE, LDE. Okay, and the ultimate stress of the road DE, this one is 280 megapascal. This one. Okay, so we have to determine this P and also deflection at point G. Also the deflection at the point G, meaning that it's going to be triangle. Okay, because you pull that point G. Okay, so first, yes, do not forget to draw the free body diagrams. Okay, if you look at here, that this is FDE. Okay, FDE for that point. Okay, please remember, just you draw this free body diagram. Okay, you draw this only this bar. Okay, no need this one, no need this one. Okay, because this is going to be this side. Just represent by using a arrow. Okay, so FAC and also FDE. This one. Okay, so if you look at here, is given the strain 0.0012. Okay, so you have to since we want to determine the FAC first, right? FAC, this is unknown. It's many unknown here actually. FDE we know, P is unknown. So the important thing is FAC, okay, because it's given a strain of EAC, epsilon AC. So we have to determine the what is it, stress. This one delta, right? Not stress. Okay, delta the deflection. Okay, delta AC is equal to, this one is 6 times 10 negative 4 meter. Okay, the deflection. Okay, so we can determine the FAC. So this one is just substitute into this one. Okay, ECA lah. Okay, because sigma, right? Sigma is equal to epsilon A. Okay, L. So just substitute, you can get 302.4 kilonewton. Okay, this one. So you can get this one. Okay, 304. And then you have to determine FDE, this one. This is also unknown. This is important. Okay. So how to determine FDE? So if you get here that by using a trigonometry method, okay, the common triangle rules, trigonometry, right? Trigonometry. So if you look at here, this is just highlight as a, this one is as a green. Eh, green lah. And highlight this one, DAC, blue. Okay. So if you look at here by using a trigonometry, cos theta equal to x divided. So this one divided by x divided by dE lah. Cos. This is a theta. If you still remember. So for trigonometry, right? Theta. X, Y, Z. So y divided by z lah for the cos. Okay. So we can rearrange this equation. Okay. So if you look at here that the diameter, because this is only from this one, right? Okay. Okay. So we can get this one. Okay, the diameter is only 0.3 lah. Okay. Wait. 3.5. Okay, so this diameter is going to be the angle is going to be the same. Okay. So this one is 3, this one is 5 lah. Okay. So and then we can get our first equation lah. Tens this one lah, x divided by y. Okay, meaning that this one lah, y divided by x. Okay, so this one is 4 divided by 3. Okay, 4 divided by 3, equation number 2. So for the delta AC, so if you look at here that what is it? Delta AC is equal to divide by 0.2. So we can get this one also divide by this one. Okay. So just by using a ratio, delta AC divide by 0.2 and y divide by 0.2 because the angle is the same. Okay. So meaning that DAC and y same, right? And then 0.2 here. And this one is 0.2 plus with 0.3 minus x. This line plus with this line. Okay, so you can get equation number 3. Okay, so that one. So from 2 and 3. Okay, this one, right? So you just substitute this y lah. So this one. Or x. Okay. So we can get delta A, AC. This one. Okay. So we can get delta AC as well as x lah. X is the length. Okay, so we can know this length. This is unknown, right? Okay. So length we know. And then we can determine the DE. Okay. So that is the DE lah. Okay. So and then we can determine sigma DE because we know the deflection, right? So if you rearrange these equations, you can get the sigma. Okay, and then you can determine the force for this one because sigma is equal to F in. So just rearrange and you can get 1, 2, 2. Okay. Okay, and then we have to determine FBD for bar BCEG. Okay. We have to draw a free body diagram lah, FBG. Okay, because we want to determine the deflection at point G as well as force at point P. So since if you look at here, I think we have to do a moment at point B lah. Okay, because this is we have to unknown. Okay, if you want to do the what is it moment at point G also possible, but you have to define By and Bx also. Okay. Any point is possible. Okay, it doesn't matter. Or you want to total fx total FY also, you can use this one, total FY, but you have to determine BY first. Okay, there's a two unknown here actually. If you want to to use a total FI, so the easiest one and to reduce the number of unknown is we use total MB lah, moment at point B. Okay, because this one is going to be 0. Okay, only we have one unknown, so directly we can determine P. Okay, so if look at here, if we do a pop moment at point B, so FSC we know, FDE we know, we just determine P lah. So we can get value of P. Okay, so by using a method of trigonometry, okay, this one divided by this one and this one divided by this one. Look at here that delta AC is 0.2, delta G, right, 0.4, 0.6. This one is this one delta G and 0.6 lah. This one, right? This one 0.2, 0.2, right? So rate lah, we use rate. And 0.6 this one. Delta G here is the ratio, right? This one, this one. This one, this one. Okay. So we know that delta AC already. Okay, so we just determine delta G. Okay, and we can get delta G. So meaning that is a deflection on the downward. Okay, go down. Okay. So 1.8 millimeter. Because we apply, I think it's quite, this one 18.85. The force is 8.5. Okay, 18.5. 18.85. Okay. So definitely if you look at here, the deflection is going to be downward from the picture, right? Because you pull this one. Okay, and this one is tension, this one is tension, this one is fixed. Okay, so then for the knowledge of the trigonometry is important. Okay, I hope that you can master this because you already learned this in the mathematical engineering, right? For the trigonometry method, even for the static. Okay, knowledge from the static, you learn already this one. Okay, I hope there's no problem. So any questions before we stop? So we finish. I've already upload or not this tutorial for the chapter 2. QR code you can in WhatsApp group. Apa ni? Henry. Oh, QR code you can scan in the e-learning. Okay, I put there before I close at 11 o'clock. Doctor, can I get the recorded video of chapter 2? Okay, okay. Sorry, I forgot to upload in the e-learning. In WhatsApp group. Who's that? Nurul Nabia. What do you mean by in WhatsApp group? Nabia? Ada tak? The slide dah upload kat WhatsApp dah tu. Oh, already. Okay, I give you the already. Okay, okay. Okay. Okay, if you have no questions, just